Jambo, we continue with the next topic of our syllabus, which is longitude and latitudes. The objectives of this topic are: 1, to recall arc length and arc length ratio, apply arc length ratio to work out arc length, distinguish between a great and a small circle on a sphere, relate radius of a small circle, small letter r, and the radius of a great circle, capital R. Use geographic coordinates to locate a place on the Earth's surface, and therefore be able to label latitudes and longitudes. Calculate the distance on the Earth's surface. That distance is along parallel of latitude, along a longitude. The distance, what we call the shortest distance between points on the same longitude. Be able to convert kilometers to nautical miles and vice versa. Be able to calculate speed in another unit called knots. Be able to convert kilometers per hour, which you are conversant with, to now the new unit called knots and vice versa. Be able to determine change in timing with change of longitudes. So we start with a recall on related concepts and definitions. So the first one is, what is an arc and what is an arc length? We consider a circle of radius r and center O. So we have 2 points, point A and B, on the circumference. This portion of the circle, this one, AB, which I have labeled S1, is called an arc. But you'll notice that there are 2 portions, ABS1 and ABS2. So S1 is called the minor arc because it's a small part of the circumference. Then S2 is a major arc because it is a bigger part of the circumference. All right. Now, what is an arc length? Arc length is that distance on the circumference from point A to point B along the circumference, or the other side, the distance AB on the circumference. So again, we have the arc length for minor arc and arc length for major arc. Now, S1 is part of the circumference. The circumference of a circle is 2 pi r. So if I'm going to explain here, we can therefore say that S1 is part or a fraction of the circumference. Now, the same, going back there, theta, this theta, is also part of the whole circular angle, which is 360. So theta is also, if you bring it here, theta is also a fraction of the whole circular angle. But these two, this and this, represent the same portion. So we can say this fraction and this fraction are the same. So that is what we call the arc length ratio. Going back here, so we see that this is what I'm trying to say, that arc length, no, this one. So if we say this fraction is equals to this fraction, if you multiply both sides by 2 pi r, going back to my board, if I multiply both sides by 2 pi r, and I multiply here by 2 pi r, this one will cancel out this. So I will remain with S1 is equals to theta over 360 times 2 pi r. This one is the formula for finding arc length. All right. Now, there is something I would want you to understand. This subtet, what does it mean to subtet? Arc length arc AB is said to subtend an angle theta at the center of the circle. This arrangement is AB subtends angle theta. So AB major subtends this angle here. That angle there will therefore be 360 minus theta. So this whole angle. So this theta is subtended by AB S1. This 360 minus theta is subtended by S2. So that meaning of subtending is important to understand. Good. So we look at an example here. We have an example there where we have a circle, center O, radius 7.7, arc AB, subtends an angle of 48 degrees. Okay, so 48 degrees. So according to our formula, arc length AB will be given by the formula the angle subtended by the arc, which is 48, over the whole circular angle, times the circumference, which is 2 pi r. And you can finish. All right. So if I wanted now the major, so this is minor. So if I wanted the major, then the angle subtended by the major is this one, which is 360 minus 48 over 360 times 22 over 7 times 7.7. And that one again, you can finish later.